So if I went through the same derivation again and get to the A and C thing, I can do it differently by getting V2 prime by itself, and this is the formula again. So the basic rule is you have two formulas for your physics toolbox to be able to use here. Now, let's do some problems. In your book on page 218, problem number 57, we're given a proton, which they say has a mass of m, and the second mass is 4 times as big, so we just use 4m for that. The m's will cancel out. It's not going to be a big deal. Don't freak out about it. Trust me, you don't want the mass of a proton in there. Anyway, the velocity is 3 times 10 to the 6 meters per second. Now, I put that in parentheses because this is what I'm going to do. Since the other one is 0, the other velocity is 0, I'm just going to use the 3. And at the end, I'm going to stick a times 10 to the 6 at the end of it. If I have to change it a little bit, I'll do that. But it's going to stay the same value. And I don't want to keep sticking that stuff in there in the formula. It just gets in the way. And a lot of times we'll put times 10e or that kind of stuff. Just use 3. That eliminates all that nonsense. And then stick it in at the end for your final answer. Okay? So the formula is going to be, as we use, V1 prime equals to, and then it's going to be mass 1, which is m, plus, or minus rather, minus, I'm pretty sure it is. Yeah, okay. Yep, it's minus, minus the second mass, which is 4m, over the sum of the two masses, m plus 4m, times the velocity 1, which here is 3, and then we have plus, and then we have 2 times the second mass, 2 times 4m, over the sum of the two masses, m plus 4m, times the velocity of the second object, which is 0. Well, that's just going to drop out. Everything's multiplying, and that's a 0. So it turns out that V1 prime, in other words, the velocity of the proton after the collision, is going to be negative 3m over 5m times 3, which is, and the m's cancel out, so that becomes negative 9 over 5, which is a negative 1.8. And now I put it into times 10 to the 6 meters per second. Now what does that negative mean? It means it's going the opposite direction that it came at, that other object. So it hits it, goes bing, straight back, hopefully. V2 prime, using the formula that we just derived, is 2 times the first mass, which is just m, over the sum of the two masses, m plus 4m, times the original, which is 3, or 3 times 10 to the 6 meters per second, minus, and then m minus 4m on top, and m plus 4m on top, on bottom rather, times again 0. Get out of here. So now I have 6 times 3, which is, 6m, m plus 4m is 5m, m cancels out, 6 divided by 5, the calculator is 1.2 meters, forgot the times 10 to the 6, gotta put that in there, times 10 to the 6 meters per second. And there are your two velocities. Using that formula with incredible derivation saves us both through time. Okay, so that is an example of how you can calculate both new velocities based on the old velocities and masses that you have in a real life setting. Okay, so all your elastic problems, that's how you do it, using the formulas that we derive. Okay? So make sure that's in your physics toolbox. Next one I want to do is an example of an inelastic collision. Now, an inelastic collision is attacked differently. We don't approach it as things being equal. Things tend to be not equal. So we got to come up with ways of calculating what you're asking for. So let's take a look at what's going on here in number 59 on page 218. Okay, so your first velocity, okay, what's happening here is you're dropping a ball and it hits the floor at contact with the floor at 8 meters per second. Now, I want to throw in a little something about a previous assignment when we had kinetic energy. And a lot of you kept giving me these goofy answers for when the ball makes contact with the floor, the object, or whatever it was I had. If you had like 15,400 kilojoules, or I'm sorry, joules of potential energy and 0 kilojoules of energy at the top, the sum is 15,400. Just as that object makes contact with the floor, it's going to have maximum kinetic energy and 0 potential energy. So that means the maximum potential energy becomes the kinetic total energy is the maximum kinetic energy is going to be what the potential energy was on top, 15,400 joules. Now, one other note before going on, doesn't really have anything to do with this, but it is important to keep in mind this. One of the problems I put in there is what is it going to be at halfway down? And you guys gave me two different numbers. Now, I understood how you did that as far as when you calculated for one and then you subtract 15,400 from the other. Didn't need to do that. If it's halfway down, guess what? Yeah, kinetic energy, potential energy are supposed to be equal. You just take 15,400 and divide by 2. All right, so let's get back to this thing right here. We know that the kinetic energy, as it makes contact, is going to be equal to the potential energy we had at the top. So EK is equal to 1/2 times the mass times 8 meters per second quantity squared. Okay? So that means then that this is going to give you 32 M. We don't know what the mass is, but who cares? We're going to compare it to this thing right here. All right? So that was the total energy of the system. Because there's no potential energy when it hit the floor. 0. Okay? Now it says on the rebound only rolls 0.25 meters. Well, that's potential energy, all potential energy when it reaches the very top. So EP is equal to mgh. Well, M is M. We don't know what it is, but we know it's, some mass, same mass that was that thing up there, because it's the same object. Times G, which is 9.80 meters per second squared, times 0.25 meters. And when you do that, 2.45 M is your answer. That's the mass, or potential energy. Okay? Now, the question is, what fraction of the kinetic energy period was lost on the rebound? You simply take the amount lost is the 32, and I'm going to get rid of the M. Well, I'm going to get rid of the M because it's all going to cancel out. Well, I better leave it in there and then cancel out later on. So 32 minus 2.45, both multiplied by M, divided by the maximum we had, what we started with was 32M. Oh look, the M's cancel out. Oh boo-hoo. Times 100, and we lost 9 92.5%. A bunch of energy loss in this problem. All right, so that's how you do an inelastic collision, and the previous one was an elastic collision. Okay? Your assignment, which I forgot to write down, so I'll put up here right now. Pages 218, 219. 58, 60, and 62. Have fun.